So, computer and Clojure, a thing. Clojure is a language that I've used for several years. I started using it when I was working at a company that's local called Cognitech that some of you may have heard of. That's what they primarily use it for. But I've used it every job since until now, where I'm working at the Iron Yard, powered by Smashing Boxes, as a Ruby on Rails instructor. So it's a lot of fun to be able to get back out and talk about Clojure some. Clojure. So people get scared when they hear Clojure because it has all these words in it that they have this sort of mystic aura about them. Functional language, you hear that thrown about. Lisp, you hear that thrown about. Most people's exposure to Lisp is maybe college if they were lucky, or from some guy with a beard who cornered them at a conference and wouldn't quit talking. One of those two situations. Functional, it sounds like math, and it is. And a lot of times when you look at it, you see an example of functional programming. It looks like the least practical thing on earth, and you go, what in the world? Why would I use this? Clojure, I put all-purpose here, but what I really wish I had put is practical. It is a practical functional language. It's one that can be used for just about any task you set your mind to. It does have a list syntax. You're going to look at that. It's not as scary as it sounds. But that is the one thing that often throws people off. I think fear of syntax is sort of the hobgoblin of tiny developers, so it doesn't bother me too much there. The last thing about it is that it runs on the Java virtual machine. This is a really big boon for lots of reasons. It makes it very performant. It makes it where it runs in lots of places. It makes it where you have interoperability with any library written for Java out there. So the language is parasitic in a way. It runs on top of this machine that was written for Java, but it's used for plenty of languages now, Scala, JRuby, all these different places. It runs on top of that, which gives it a lot of capabilities. This is why I use it. The why part of using Clojure is really up to you and your problem domain. But these are the reasons I use it. I use it because it's really simple. I recently taught a class to a group of women. It was called Clojure Bridge, much like Rails Bridge. It's a day-long seminar specifically for women to bring them into a particular field. And most of the people in the room had not developed before. I find Clojure to be simpler to teach to people who haven't developed before than any other language I've tried to teach people, because there's just not that many moving parts. You get it quickly. Now, for someone who's been developing a long time, it's super hard, because you're like, where are my objects? Where's going on? I need my power. It's in there, you just don't know where to find it yet, but you will. I also find it immensely fun to write. That is a personal preference. You might not find that to be true, but I experience so much joy when I sit down to write it. I spent 1.5 years working on the same Clojure project every day, and just every day was a delight to really dig in that code, even though the code base got very, very large. It was super understandable. I had fun every time I was in there. Just a fantastic experience. And Clojure, and let me say up front that while it's, I said all-purpose, it's very good at doing web things, and that's primarily what I've done with it. We're not going to talk about the web tonight because I'm trying to give a gentle introduction. You have to sort of go up a couple of stairs till you get to the web floor. So we're not going to talk about the web very much, but it is very good for web development in certain ways, which I can answer questions about. But you may have just heard about it in passing, right? It's not something, like how many people here have written Clojure just even for fun, right? So looking at these three people, you might think, well, this is a really niche language. Like, why would I spend my time on that? I'm going to come back to this slide because I was getting at this. It's not a niche language is the crazy thing. It's used by huge companies, and it's being used a lot in the financial industry. That's the one I didn't put on here because most banks do not announce what they use. But I know both from personal experience working on consulting projects and just from talking to friends, it's being used widely in the financial industry because of some of its capabilities. But it's being used by Netflix, Amazon, Staples, Walmart of all places has a very big Clojure shop inside of Walmart Labs. One of the best Clojure developers in the world worked until recently at the New York Times, and a lot of their really amazing visualizations that you see were all written in Clojure script, which is a version of Clojure written for that compiles to JavaScript. And lastly, I worked at the Consumer Financial Protection Bureau, so I know they use it because I introduced it. Clojure's good at many things, but these are some of the things that people most often use it for. Data processing. the entire language is based around the concept of data. It is not an object-oriented language. It is a language that deals with simple data structures. And so that lends it to being very, very good at data processing. It's also got a very simple and easy way to implement concurrent code. If anyone's tried to implement concurrent code in any language, including Clojure, you know it is somewhat of a beast. It can be much more of a beast when you're just dealing with raw threads. Because Clojure is a language where all data is immutable, you don't have the sort of situation that you often have in multi-threaded code where data is changing out from underneath you and you don't know why, and it's a big mystery to you. It's good at web applications. It's better at doing API type stuff. There's no big web framework for it like there is for Python or Ruby or Node.js even. It tends to be composed of smaller libraries. I find it really great for building APIs, though. That's been where I found it to be just fantastic. And I think it's good for most things. When I say everything, I should put the caveat there. It's terrible for any shell scripts. But that's really the one place where I wouldn't ever want to use it. Because it runs on the Java virtual machine, if anyone's dealt with Java or any language that runs on the Java virtual machine, you'll know they're very speedy, but they have kind of a slow startup time because it's loading a lot of things into memory. And so Clojure, often when I'm running a Clojure program, it'll take a good 5 seconds to start, but then crank along. So for small shell scripts, probably not your thing. So let's talk about the basics of Clojure real quick so we can see really cool stuff instead of small, tiny stuff. This is just the I'm dumping a bottle of water on you introduction to it here. So this is what it looks like. If you saw Lisp language and you didn't know what I meant that there's a lot of parentheses. I meant that in every single case you'll see open parenthesis, some sort of function, in this case the plus sign, the word max, the word eat, and then some arguments. These are just function calls like you've seen in every other programming language you've used, but this is the way you do it in Clojure. It has the type of values you've seen. It has integers. It has floats. It has ratios, which are not in every language. Those are really fun to work with. If you have worked in Ruby, then this thing called a keyword is exactly like a Ruby symbol. Similar concept. In fact, identical concept, I should say. Strings, booleans, all the things you're used to. So nothing that unfamiliar, nothing that weird. And then it has 4 types of collections. And this is where it starts, you really have covered most of the basic data structures in the language. We're not really going to focus on lists and sets. They are a little bit more specialized and not used as much. But a set is what, if you remember what a set is in math, then you know what a set is. And if you don't, I am not going to explain set math to you tonight. A list is just a linked list. You don't end up not using that quite as much. So we can see here a vector is just a list of things in order, an ordered list of things that we have. A map is a simple key value structure. So in this map, I'm saying that this is a collection of data, and in this, the word first maps to the word Thorin, and the word last maps to the word Oakenshield. So this could be a person, a dwarven person, perhaps. Yeah. I have. Oh, yes.
You just said it was the list was an ordered list?
Yes.
So
well, the list and the vector. It's funny, list is a word that makes sense to use, but I'm not using the Clojure meaning of the word list as much as the colloquial version.
Explain ordered since US precedes I. US dash.
Ordered as in the order that you put things in there. 0, 1, 2, 3, just like an array in any other language. Okay. A vector is pretty much what you think of when you think of an array in any language. A map is what we know in Ruby as a hash, as a dictionary in Python, as an associative array in PHP, any of those things. Okay. Assigning names to things. So it's not this equals that, it's def, but similar concept, right? I want to say I have 3 mangoes. I define mangoes to be equal to 3. I define oranges to be equal to 5. I can add them together. It's all, at this point, just easy peasy. And then lastly, and this is really the last major piece of syntax I'll show, are functions. So functions start with def in. You may in Ruby see def. You may see whatever you have in whatever language you use. A name, what they call a doc string. That's documentation built in there, but documentation you can pull out very easily. The function keeps that information around. A set of arguments. So that first argument there in cube is just x. I'm able to pass one argument to it. I'll call x. And then I return whatever is at the bottom of my function. So it's an implicit return. That's going to return x times itself 3 times, the cube of it. Or I could have a function that's called say hello that will print out hello and my name and be done. And now we have functions. So we have enough to really build cool stuff with. So let's do that. So in Clojure, the primary thing that you work with is not objects, but it is data. Data being the collections we've already seen. It's funny, when I start talking about Clojure with people that have been programming a long time, I often will compare it to the programming language Perl, which freaks people out because they think, oh my God, that's terrible. I remember using Perl, it's horrible. Which partially I like to do because I'm a bit of a troll, but also because it was a language that in object-oriented programming was so hard that you never did it, right? You stuck with data. But the sticking with data part was the part that was actually fun. You had these nested data structures you could walk through very easily. So I've got a little code here just to start me off. That part's not important. So modeling data with collections. So instead of objects, we use vectors, maps, other collection types to model data. And to give them behavior, we use functions. So I'm just going to make some data here. My shirt might be topical for the talk. So I've got, I'm building a game here, a game that is in a fantasy world full of magic and swords and danger. And in here I've got a goblin. I've got some statistics about a goblin that I'm going to need to know to write the game. For example, it's hit dice. That's, how many hits it can take. Or its armor class, how hard it is to hit. Things like how much treasure does this thing have? That's exciting. And what weapons does it have? So I have all these on here now. I've got a goblin, an owlbear, a snake. And again, I can use data to say I have a set of monsters. Let's use a vector to make those monsters. And just to show those in context, I can go in here and get any one of those. So I say snake, and I've got its information. I can say these keywords that you see here, you can use them to pull information back out. So if I want to say weapon, goblin, I can find out what its weapon is. It has a dagger. Fantastic. So far, so good. I've really got the ability to dig down into what I have here. But I want there to be some behavior, something I can use here. So this is the first time we see behavior with data. Right here, I've got a function just to give me an 8-sided die, which really is used a lot in this game. This nameless game I'm making here. I was just nominated this morning for Best Writing in a Role-Playing Game, which is super exciting for me. So yeah, that's cool. Anyway, I thought about that when I was doing this. So it kind of inspired me in writing these. So this is a function I've written that will take a monster. It'll get its hit dice. Let is just another way to make basically variables. And then it's going to return a new monster with an actual number of hit points. This hit dice is just a number that you use that determines a random number of hit points you use in this game. Hit points being, how much damage can this poor owlbear here take? And I run that and I get back the owlbear, but he has a new key, hit points. This is where immutability comes in. So in many languages, something like an array or a hash would be something you could change. You can add a new key to it. You can remove a key from it. You can update the data. Not so in Clojure. Every single thing in Clojure is immutable. So what I've done here is not changed owlbear, but instead returned a new map. You can call them maps, but hash, whatever fits your build, that has its updated data. You might think, wow, that's going to take a lot of memory, and strangely it doesn't. The reasons why are arcanely technical, and I would love to talk with you about them. But probably not everybody wants to know right now. Just trust me at this point that it doesn't kill your memory. This is really nice, though, because that owlbear is never going to change. If I need to have an updated version of it, that's fine. I can do that. I can use that. But I never have this confusion about, did this mutate out from underneath me in this other function? Why do I have this bug? I expected this to have this one piece of data, and it doesn't anymore. That doesn't happen to you. Likewise, there's functions in Clojure that take other functions. This is part of the functional aspect of it. So here I've said map, and I have to say this is my one amazingly big complaint about the language, that there's a function called map that has nothing to do with the data structure called map. Good God. It's so frustrating. But map, if you've used a language that has a map or reduce in it, you may have seen this. This says, take those monsters and run this function over each one, collecting it into a new collection. So now I've run this, and I've taken my goblin, my owlbear, my snake, and they all have hit points, as you can see. So I'm able to quickly generate this and bring this back. So just by putting together simple functions, I can alter my data and do what I want to with it. Now that we've seen this, I want to go back to the slides for a minute and talk about something called sequences. So we've seen that there's 4 different data structures in Clojure, but Clojure has this concept of sequences, which is this abstract data type. That is a data type that you never build a sequence. You build a concrete data type. But a sequence, you can apply it to, that's tiny, to many different concrete data types. The reason this is exciting and useful is it allows you to use the same functions on anything that's a sequence. So lists are sequences, vectors are, sets, maps. So are strings, so are files in a directory, lines in a file, rows in a database, all of these things. And this is just a quick set of them. You can make your own sequences as well. So anything that is a sequence, you can map over it. You can take the first one of it. You can grab 3, drop 5, whatever you want to do. You have the same set of functions that apply to all of them. Usually on this slide, in almost every Clojure talk, they put a great quote by Alan Perlis. Let's see if I can remember it off the top of my head. Which is, I would rather have 100 functions that work on one data structure than 10 functions that work on 10 data structures. The complexity of those 10 functions that work on 10 data structures is much higher because you have to remember what works with what. In this, everything that works with sequences works with all of these things. This is a wall of text. I am not even going to remotely go through it because it is just meant to impress you. That is all it's there for. Here are a lot of functions that work on all sorts of sequences. Just to throw 1 or 2 out there. Filter. I want to go through a sequence and filter out something that meets some question I have, some predicate. Cool, I can do that. Doesn't matter what type of sequence it is, I can do that. I want to grab the first 10. I can do that. Oh, here's some more sequence functions. Why not, right? I want to drop the last one on it. No problem. I want to build a new one. Take 2 things and zip them together to make a map. No problem. Can do that. Works with all of these. And of course, map and reduce, the big 2, work with all of them. This is a good place to point out that sequences are lazy as well. Almost always. It's not entirely true, but almost always they're lazy. So they're realized when you need to realize it. That becomes very important when you're dealing with huge amounts of data. Let's go back to this code. Yes?
You mean that they're realizing in the sense that if you need like the first, second, and third object of a sequence that could be n length long, it only builds up those 3.
It could be infinite. Yeah.
Yeah.
And for sort of a practical example of file sequence, right? Or line sequence. So we'll give you the lines from a file. If I say take 10, it doesn't read the whole file in a memory. It reads those 10 lines, right? And I say take 10 more. Okay, then it reads those 10 lines in memory. But it doesn't realize it. Realizing meaning actually execute the code to do it. That also means you can chain these things together. So if I want to map something over it and then take a part of that and map something else over it, map something else over it, I'm not processing it 3 times. I'm processing it once as it goes through, as I finally ask for elements from it. Let's go back to our code. Cool. So people at this point always freak out and go, but if I don't have objects, how do I not have types of things? And so you could just add a key, why not, to say, hey, this guy, Thorin, he's typed character. Maybe that'll suit you. Maybe you need a more formal way to do it. We do have records. Records work just like maps, but they have names. They have a little bit quicker access for the elements that you put in them. And they have a Java class. So if you need to interact with Java, this is useful. But otherwise, it's, for all intents and purposes, the same as a map. So if you need those types for whatever your code is, you can have them. But types matter less when your polymorphism is based off the shape of your data. So in this function here, I'm going to take something that can have hit points. You probably noticed when we were looking, and when I say probably noticed, I mean definitely not because I zoomed through it, unless you're a giant D&D nerd, that Thorin here has hit points already. Characters in the epic game of adventure and imagination called Dungeons & Dragons have their hit points already set. They're not random, but every creature you meet will have random ones. So in my function, your hit points, because I want to get the hit points of all sorts of things in my system, anything that's hit pointable. I go in here and I say, hey, if it has hit points, return that. If it doesn't, calculate its hit points and return that. And then lastly, if it doesn't have either one of those, return nil, because it's not hit pointable. It's not a thing that can have hit points. And so I see here, does Thorin and Goblin have hit points? Why, yes, they do. You may have noticed the Goblin's changed. I'll run that again. Because he can have random hit points. Thorin's never changed because he has hit points, obviously. Then I get into a bigger thing in my game. So in my game, I'm going to want to have a couple of things. I want to have characters. I want to have creatures for those characters to fight. They need to have weapons, of course. How could they fight without weapons? Fisticuffs will just not do in a world of adventure. And then I need a dungeon for them to go into. For that is in the name of the game. That would be silly if I did not. So here I have completely nerded out and made a bunch of different sizes of dice. So I made myself some functions to do this. You'll see here a lazy sequence being used. So here at the top, I have a function called create die, and it calls a function called repeatedly. Repeatedly makes a sequence that goes on forever. It will continue to call the function given to it until the end of time. So create die returns a function that gives me a random number between 1 and n, where n is the thing I've given to it. So using this, I can roll that die, so to speak, over and over and over. It's an infinite list. Made a set of weapons. Not that important there, but here's where it gets useful. So here I am using sort of idea of using data. All I care about is, does this thing have a weapon? If it has a weapon, then I can figure out how much damage it does. If you remember, and if you don't, let me go up and look at it here. These different creatures had the goblin and the snake have one weapon each. The owlbear, he has 3. He has 2 claws and a bite. His beak. If you haven't seen an owlbear, you really need to see one. By which I mean I'm going to Google pictures of owlbears right now because what is more awesome than an owlbear? I tell you, nothing. So claw, bite, as you can obviously see here. There's no real question about that. So my damage function needs to be able to handle that, of course. So in here, this gets kind of complicated, I'll admit, for someone who hasn't seen the language before, but let's break it down. This is where we'll spend most of our time. We'll break this down. So look here in the center, right here, saying if my weapon that I have on this creature, this thing, whatever, whether it be character or a creature or a trap or whatever, if it's a collection, then return it. Otherwise, make it into a vector, because I'm going to need a collection for the next thing I'm going to do. For I am going to map over those, each one calling the die that it does for damage. I know the die that it does for damage because I have it stored in this hash here. And then it's going to reduce that into one sum. So it's going to roll those dice and return a number, whether it has one weapon or claw, bite. So you can see here, it's already run it once, and they did that much damage. But if I run it again, they'll do different amounts of damage for this rolls random dice each time. The owlbear's damage did not change, so there we are. Obviously, owlbear is a dangerous thing to walk around. Thorin has 14 hit points. Right now, Thorin would be pretty sad in this situation. He would be a dwarf with saying his last words. So maybe Thorin should stay away from owlbears. But I need more. I need more to complete this game. I need a dungeon. So again, this is where, obviously, in Ruby, our language, it gives me objects, where that is it's nothing about Clojure is a bash on those by any means. That's the tools that you work with that language. You work with different tools in this language. In a language where I have the tools of objects, I would definitely reach for them here, right? I would want to have a dungeon and have characteristics, and it would have somehow a map of rooms and so forth and so on. Here, I'm just going to use a map again. Got my rooms. Some of them have treasure, some of them don't. Some of them have monsters, some of them don't. All of them have exits to somewhere else, so I can see where to go. This is a simple little 4-room dungeon. And here is another example of polymorphism. So people think, well, without objects, how can I have polymorphism? How can I decide what to do? I find it actually easier because when I think of polymorphism, I really think of I call the same function or the same method in terms of objects on many different objects. Well, here, I'm going to call one function on many objects. Luckily, Clojure gives us this concept of a multi-method where I can dispatch based on something. So here I'm saying to get the treasure from something, I look to see its treasure type. Right? This is a function that I call. I could have as easily said this as thing, treasure type thing, but as you may have picked up, keywords work as functions. So I can just give it there as a function. And then the first argument to each one of these def methods is what we're dispatching on. So if it was treasure type A, then do this, B, do this, C, do this, or if it's something else, then return nothing, because I want this to work for anything, whether it be a creature that might have treasure, or a room that might have treasure, or maybe later on I'll have a chest that has treasure. All these different things. I want it to be able to work. So I run that, and then I go in here and say, how much treasure is in room 1? Room 1, by the way, has treasure type A, for it is the first room of the dungeon, and we would really not want to give away all the treasure there. So 4 silver and 20 copper, a pittance. I can barely buy ale with that. I need to go further into this dungeon. So here, I've made another function. This one is the most complicated function we're going to see tonight, and the last, for that matter. So this one says, if the thing I give it is associative. So here we see another sequence function. Maps are associative, so are sets. All sorts of sequences can be associative. By associative, we just mean that there's some key that is attached to some value. In other words, it's a reference between two things. So if this is associative, and it contains, I asked if it's associative first because contains needs an associative sequence. So, and it contains treasure type, then add some realized treasure to it. Roll the dice to find out how much treasure you got and put that on there. I would use this because I may be setting up for the night. My friends are coming over. I've set out the flavored chips. I'm ready to play the game. But I pull up my module and it just says, oh, treasure type C in this room. I'm like, that will not do. I need to know how much treasure is in this room, for I will give it to them when they defeat the beast within it. So I could use this to find out how much treasure is in any one thing. I use a function that comes with Clojure called postwalk. Postwalk goes from a bottom-up walking of any tree or any sequence and goes through and will run this method against all of them. So just to, so we'll run this, and you'll see pprint dungeon. So pprint just prints something out printed very nicely. So we can see here that we have room 1. Whoa, I made that way too big. My apologies. So room 1 has treasure type A and 2 exits. Room 2 has some monsters. Those monsters each have treasure type A, for they are carrying treasure in their little coin purses, greedy little goblins. The room doesn't have any, of course. Room 3, snakes don't have treasure. Where would they keep it? They're snakes. They don't even have hands. But they often lie atop piles of it. So this room has treasure type B. And then lastly, we've got an owlbear that has treasure type B. And the room has treasure type C. So when I run this, will it realize the treasure for all of these things? For each monster that I might defeat and every room? Why, it does. In room 1, we'll get 11 silver. Well, that's better than we were going to get before. These goblins, they're loaded. 11 silver each and 38 copper. My word. In room 3, 5 gold. Why, I might be able to buy myself a new sword with that. And lastly, in room 4, between this owlbear, not that rich of an owlbear, just 1 gold on him, but the 20 gold in this room, I could buy myself a set of plate mail. If I survive the encounter with the owlbear, which I probably won't, for it has 2 claws and a bite.